Hi, I'd like to do another example problem for you to illustrate the use of the quadratic formula in physics. So here's our sample problem. A rocket is fired vertically with an initial velocity of 200 meters per second. We'll make that 4 sig figs. Our part A, determine the maximum height it can reach. Okay, that's our first part. So, you have this rocket going straight up, straight down. Leaves the ground with an initial velocity of 200 meters per second. Velocity at the tip top, 0. Slowing it down, we have negative gravity, and that's all we know. So we want the maximum height. When I don't have a time variable, I look on my sheet and there's one equation that does not include time, and I like to see if that works. We're trying to find d, a displacement. That's our unknown. So our basic equation, vf squared equals vi squared plus 2ad. Rearranging to solve for d, I'm going to bring the d to the other side. I'm going to have vf squared minus vi squared divided by 2a. Be careful with that. Make sure you divide by both 2 as well as a. So I'm going to go to the next page and put in our numbers. So vf was 0, minus 200 was vi, meters per second, squared, all divided by 2 times negative 9.8 meters per second squared. Remember, we're finding d. Do your math, and I get a value of 2,040 meters. Okay, the negatives cancel out. And you might want to round it to 241, huh? Either way's fine. All right, so now we know the height. Let's go to part B. Determine the time it takes to reach this maximum height. Go to the next page. Determine the time it takes to reach the maximum height. We know VI is 200 meters per second. We know VF is 0 at the tip top. We know acceleration is negative 9.8 meters per second squared. I think most of you know which equation to use. We take our basic acceleration equation and rearrange to solve for time. So time is equal to VF minus VI over A. So time is equal to 0 minus 200 meters per second divided by negative 9.8 meters per second squared. Divide 200 by 9.8. Check my answers, and I have 20.4 seconds. That's how long it takes to get to the tip-top position. Let's look at part C. Part C asks, states, determine the instantaneous velocity at the end of 30 seconds. Determine the instantaneous velocity at the end of 30 seconds. So we want t to equal 30. Vi is still 200. A is still negative 9.8. And we're trying to solve for Vf. I'm back to my original acceleration equation, but I want to solve for Vf this time, so I have Vf is equal to At plus Vi. So our Vf is equal to negative 9.8 meters per second squared times 30 seconds plus 200 meters per second. Using your units really helps keep things straight. You can see how your seconds will cancel down, so you have meters per second. Your VF, once you calculate, negative 94 meters per second. And just check my calculation. Yeah, so that's exactly. What does the negative mean? It's on its way back down, so it gives you a direction. Our last part asks, when will its height be 1,000 meters? When, so we're looking for a time, will its height be 1,000 meters? So we want D to be 1,000. We still know VI, 200 meters per second. We still know A, negative 9.8 meters per second squared. But T is our unknown. So here's where something new comes in. You could work this out bit by bit with algebra, but we want to use the quadratic formula, or I'd like to show you how to use the quadratic formula. If you think about this basic equation, D equals VIT plus 1/2 AT squared. Now, T is our unknown, all right? But I know everything else. So I'm going to rearrange this and bring D to the other side. So I have 0 equals VIT plus 1/2 AT squared minus D. Now I'm going to rearrange this just a little bit. In math, you usually have ax squared plus bx plus c. So right there is our x squared. So I'm going to write 0 equals 1/2 at squared plus vit minus d. All right, so now it's in the same format as you're used to from math class. Now let's plug in our numbers. We have 0 equals, let me move over so I have more room. Oops. So 0 equals 1/2 times negative 9.8. Here I am going to leave out units just to simplify the look of it, plus 200 meters per second times t minus 1,000 meters. Think about what 1/2 and negative 9.8 will give you as a product. So now we have negative 4.9 t squared plus 200 t minus 1,000. Negative 4.9 is your A. B is your 200, and c is negative 1,000. Now you can work out your quadratic formula, long form, or if you wait till tomorrow, I will download a program if you have a TI 83 or 84, and called Quad Form, and it does the actual algebra of the quadratic equation for us. So that's how I got my next answer, but it'd be great if you could come up with those two values, and I get t to equal 5.83 seconds, and we have the other t, I'll call it 1 and 2, 34.98 seconds. So think about what this means. You have this rocket, went up and down. The maximum height of the rocket is 2,041 meters. So it's going to reach 1,000 meters going up and coming down. It took, to get to the tip top, 20.4 seconds. So your T1 tells you how long it took to go up to 1,000 meters, and your T2 tells you at 34.98 seconds, that's when you're going to find it at 1,000 meters on the way back down. All right, I'll see you tomorrow.